Okay, we're given the equation square root of x minus 4 equals 5. How are we going to solve that? Well, that should be fairly obvious that if we square both sides of this equation, then we're not going to have that square root there anymore. And that square root kind of keeps x in check. We can't really deal with x till we get it out of the square root, and this is the way to do it. So the square root of the quantity x minus 4 quantity squared is going to equal 5 squared, and of course the square of the square root of x minus 4 is x minus 4. 5 squared being 25, we get x minus 4 equals 25, with the result that x equals 29, and that's completely obvious. And this checks because we put 29 back into the equation. We get 29 minus 4, which is 25 under the square root, and the square root of 25 is 5. Okay, so that's very straightforward. Now, let's see, I'm going to go on and solve this problem, but I want to come back to this note here, which takes off on this problem a little bit. But let's go ahead and do this one. Okay, same thing. We're going to square both sides. And I've got both sides squared here. When we square both sides, we get x squared minus x. On this side, we get 9 on this side. We recognize that this is a quadratic. Okay, so recognize that this is a quadratic. So we know to put it in standard form of a quadratic, x squared minus x minus 9 equals 0. And then we can attempt to factor that, but 9 doesn't have good integer factors. So that's not going to work. A is 1, B is negative 1, C is negative 9. We plug those in, and we get x equals 1 plus or minus the square root of 1 plus 36. You can check that out yourself, over 2. And of course that's then 1 plus or minus the square root of 37 over 2, and that's as far as we need to take this, unless we want to just, do 1/2 plus or minus 1/2 the square root of 37. We could do that, and of course we could write down the plus and the minus separately. So it comes out in a very straightforward manner if we just square both sides and note that we have a quadratic. Okay. Now, I want to come back to this problem because this problem could have been written as the square root of x minus 4 minus 5 equals 0, couldn't it? Subtract 5 from both sides, we get the 0. Now, in writing the equation like this, there'd be no reason usually to change it to that form, but it could have originally been presented in that form. It could have originally appeared in the solution of some other problem in this form. And then you would have the problem of what to do with it. Now, hopefully what you would see is, well, if I add 5 to both sides, I get this, and this is really easy to solve. Okay? But if you don't, what are you going to do? Well, you might be tempted to square both sides. Might work, might get rid of that square root. Let's see. Well, it doesn't get rid of the square root. We can still rescue the problem, but it makes it a lot harder to solve. Still, in seeing what happens if we square both sides here, we gain a little bit of insight into what we're going to need to solve the next problem. Okay, so if I square both sides, what happens? Well, I get x minus 4 squared. And again, you should be able to square this using the special formula, or you should be able to square it using writing it down as 2 binomials. Square root of x minus 4 minus 5 multiplied by the quantity square root of x minus 4 minus 5. Use the distributive law. Either way, you're going to get a square root of x minus 4 being squared. You're going to get minus 10 times the square root of x minus 4, and you can check that out yourself, you should. And we're going to get the square of 5, which is 25. The problem then is that we still have a square root. Okay, we have the square root of x minus 4 here. We didn't get rid of that square root. Well, we can still, okay, so we still have the square root with an exclamation point. That's not good. So it would have been better to rearrange it this way, into square root of x minus 4 equals 5. We could still redeem this. We could get the x minus 4 and the 25, and we'd subtract all that off, get all that on the right-hand side, and then square, and then the square root would go away. We would end up with a quadratic, at least for a short time, and it might get confusing. We might get extraneous roots, but we could do it, and if we're careful in checking our solutions, we would still be able to get a good solution. But if you see something like this, you really want to do this. Now the next problem isn't going to be that simple because we're going to have two square roots. So here's the promised problem. Square root of x minus 4 plus the square root of x plus 2 equals 1. Now we can't write that as just some square root equals something and square both sides and get rid of the square root. It's not going to work. So we square both sides. Now we don't want to succumb to the illusion that if we square both sides we get x minus 4 plus x plus 2. That's not how we square a binomial. And this is a binomial. It's this plus this. It needs to be squared. It's going to be squared either by the special product or by multiplying it as two binomials and being very careful. When we square it, we're going to have this squared, we're going to have this squared, we're also going to have this times this, and we're going to have this times this. We get quantity x minus 4 squared, which is going to give us the x minus 4. We have the square root of x plus 2 quantity squared, which is going to give us x plus 2. But we also have 2 times the square root of x minus 4 times the square root of x plus 2. And that means we've still got square roots here. Of course, the product of these two square roots can be written as the square root of the product of those quantities. So we get all this into one square root. And we combine our x minus 4 with x plus 2 to get 2x minus 2. And that's very straightforward. And now what do we have? Okay, it doesn't seem like maybe we've made a lot of progress, but we have, because now if we subtract the 2x minus 2 from both sides, which is going to give us 3 minus 2x on this side, and the 2x plus 2 will subtract off on this side, we've got 2 times a square root equals something. So we essentially have a square root of something equals something. And if we square both sides, the square root is going to not be there anymore. So we do that. We square this, we square this. And we get here 2 squared is 4, and the square root of x minus 4 times x plus 2 is just x minus 4 times x plus 2. Over here, the square of 3 minus 2x is 9 minus 12x plus 4x squared. Okay, so we've gotten rid of that. We've gotten rid of all the square roots, but it took us 2 steps. Now you need to understand this. Okay, so we proceed to solve this. Now this video is getting a little long, but I think I'll pursue it. Okay, I think I'll persist. That's the word I wanted. Now, I've just written the whole thing up here again as it was down here. So what do? Well, we multiply through by the 4 here, and my X got smudged. When I move these boards, I have to move them through some kind of tight places, and sometimes I get a little messed up. Okay. Okay, I've got this. And we, again, note that this is quadratic, so we put it into the standard form, ax squared plus bx plus c equals 0. And when we do that, lo and behold, the 4x squareds go away, so it really wasn't quadratic. And we just end up with 4x minus 41 equals 0. And I got the note here, dang, the x squared terms are gone. It's actually linear, and that's a good thing because that makes it very easy to solve. We get 4x equals 41, x equals 41 fourths. Now, there's a problem with that. When you begin squaring both sides of equations, you can get extraneous roots. Okay, you can get apparent solutions that really aren't solutions of the original problem. If I plug 41 fourths in here, I can see that these things can't add up to 1. Okay, 41 fourths minus 4. 41 fourths is about 10. 10 minus 4 would be 6, and the square root of 6 is already bigger than 1, much less when we do 10 plus 2. So both of these are going to be bigger than 1, so we don't have to do the detailed calculations to understand that this is not a solution up here. Both of these quantities are too big. Both of these quantities are going to be bigger than 1, and they can't add up to 1. And in fact, but you know, of course, If we've got a solution, this is the only possible solution. We don't lose solutions when we square both sides, but we can gain solutions. Okay, we can have solutions to the squared equations that would not be solutions to the original equation. Okay, so this is the only possible solution. It doesn't work. This means there is no solution to this equation. Okay, and that we can actually see by just thinking about it. In the first place, any x that works in this equation has to be bigger than 4 because we can't take the square root of a negative. And if x was less than 4, this would be negative here. X is bigger than 4. Well, x plus 2 then is bigger than 1, so its square root is bigger than 1. So this is already bigger than 1. It doesn't matter what this is. I mean, this is going to be positive, so this is not going to make the result less. This is already bigger than 1, so we're done for. We cannot find a solution. And that's what the note says here. And I'll say in my note here, the square root of x plus 4 plus the square root of x plus 6 has to be greater than 1. And that, again, means that there is no solution to this equation. So the one solution we got on the squaring turns out not to really be a solution to the original equation. And I've added the note. Thus, arrow to this, x equals 41/4 is an extraneous root. There are no solutions. This is an extraneous root. And, again, that's the only possible solution. There are no solutions.